Engineering Controls, Video 7. We're moving to the next part of the hierarchy of controls, engineering controls, which is isolating people from the hazard. Engineering controls are safety features. They're physical modifications to tools and equipment, so they're inventions that make things safer. So if you imagine going from the vintage gravity injection to the more modern, even computerized ones, it's a big difference. Or think of maybe a blood aspirator that has a special tubing valve that's added into it, to better and better machines, some that even are automated to do a lot of the work that used to be done by hand. Thinking about the height of the table and having an engineering control to be able to change the height is a factor in making sure we don't cause musculoskeletal damage to ourselves. Either using hydraulics or a manual table, you want to change the height. Proactive hazard controls. These are steps that are taken to stop the hazard before it can cause harm. Local exhaust ventilation is an example of a proactive. A fume hood, a snorkel vent, which might have the ability to move right over the area where the fumes are being created, downdraft tables that have both drainage and ventilation, or slot hood systems. All of these are engineering controls to try to reduce the amount of formaldehyde fumes in the air. Sharps are an area where there have been many engineering controls. So sharp safety features are designed to keep the worker's hands from having to directly interact with the dangerous part of the instrument. But safety devices alone do not completely prevent injuries. We have to use the safety devices correctly. With sharps handling, you want to be prepared, be aware, and dispose with care. An easy rhyme to remember. That means when you're preparing your sharps, you want your equipment to be organized. You want to have adequate lighting so you can see what you're doing. Keep the sharps pointed away from yourself or from any other user. You want to locate the closest sharps container so you can dispose of them as quickly as possible. And you're going to wear your personal protective equipment. An invention that can help with sharp safety is something like a scalpel blade remover. So there are automated scalpel blade removers like this one, where you put the scalpel blade in and it almost sounds like a little punch happens. It's battery operated and the scalpel blade is taken off. Or you might have an invention like this that you put over the scalpel blade and it has a little place where you press it to release the blade. This is different than using a pair of hemostats to remove it. When it comes to safer sharps, there are multiple inventions. So you might have a needle that has a flip-up cap. With scalpels, you might have a little plastic cover that you slide forward with your thumb to make sure that the scalpel is not open. Some sort of injection needle that you're placing has a sheath where you slide it down over to cover it. Or it has a cap that you pull down over the sharp part that could cause the injury. And there are multiple different types of capping needles. Additionally, a way we protect ourselves and isolate ourselves from danger is by managing the waste. There are many types of medical waste. In mortuary services, you might have infectious waste. We were just talking about sharps. There could be pathological waste, chemotherapy, radioactive, pharmaceutical, and just general waste. Biohazard symbol. This is one of the most common hazard communications that you will see. This is a visual representation of what we're dealing with. It indicates the risk that it poses a bloodborne or an infectious hazard, and it also tells us how we need to dispose of it. With biohazard disposal, you're going to use a leak-resistant biohazard bag and container. You might do blood-soaked gauze or any towels, tubing, catgut sutures, gowns, gloves, anything that's not sharps but is contaminated with blood or OPIM goes in a biohazard container. Sharps go in specific sharps containers. These are puncture resistant, leak proof, and labeled biohazard. These containers should be located as close to feasibly possible where the items are being used. One of the biggest dangers with sharps containers is overfilling them. Containers are designed to be able to be closed so no sharps fall out, and if it is overfilled, you cannot do that. Chemotherapeutic or pharmaceutical waste. These might be agents that are used within the deceased, some IV bags or tubing that came with them, or any other pharmaceuticals should be isolated in their own containers. So the chemotherapeutic waste container, you can see it has a biohazard symbol on it, but it's a hazard that has more to do with the drugs than, say, blood or OPIM. Metals from cremation. There may be metals that are left over in the cremains, and an engineering control is using a special magnet to remove the metals from the cremains and not doing it by hand. These metals can be recycled or they need to be disposed of properly. Radiation. We recognize it's the yellow with the 3 black ones coming out. And the rule with radiation is called ALARA, which I love because it sounds like a Disney princess name, but it stands for as low as reasonably achievable. So this is a principle designed to minimize our radiation by isolating us from the source. You need as little time as possible. Near the item, you need distance from the item or shielding. Hopefully, any interaction you have with radioactive materials is specifically having directions from hospitals, but there can be implanted devices. Great, you made it to the end of video 7. I will see you in video 8, which is the last video.